Hey everyone, welcome back. So we're starting a new unit today. It's on function types. Our first function type is going to be exponential functions. It's something that we've seen in the media based on the COVID. So hopefully, guys, you'll be able to see the situation as it correlates with what we're doing. All right. So our first aim today is how do we determine exponential growth and decay? So before we get into that, we need to talk about the objectives. Today, we want to see the structure of the standard formula for exponential growth and decay, identify the multiplier for a percentage increase or decrease, and define percent, interest rate, time, and principal. Before we get into anything, we need to know what exponential growth and decay are. So exponential growth is whenever something is increasing or growing rapidly as a result of a constant rate of growth applied to it. Okay, that is what exponential growth would be. So think about what we've been seeing when it comes to COVID. It first started off with like one person, then it jumped to about 10, and then it rapidly increased to about 200, and now it's in the thousands and hundred thousands. Okay. So it's not technically linear. Remember, linear is when it's constant throughout the entire scenario. But exponential growth, it changes rapidly where the constant rate of change is not the same from beginning to end. Okay? Exponential decay is whenever something is decreasing or shrinking rapidly as a result of a constant rate of decay applied to it. So basically the same thing, but instead of it growing, it's shrinking. So when you get into like your science classes and you start to talk about half-life, right? It's basically cutting something in half from its previous state. So it doesn't necessarily mean it's constant rate of change, but as a multiplier of constant rate of change. So when we're talking about exponential growth and decay, the formula is basically the same, but as you could see, there's one major difference. If we're growing something, it means that we're adding on. If we're decaying, it means that we are subtracting from. So just to point something out, the growth factor or the decay factor is the piece that you see in the parentheses. So the growth factor for exponential growth is 1 plus r, and as a result, that sum will be greater than 1. If we're looking at exponential decay, its decay factor would be 1 minus r, which would mean the difference in that space would be less than 1, but greater than 0. Okay? Now, what do these letters mean? A is representing the final amount, so it's like your total cost. P is the initial amount or the principal, so it's what you start with. R is the rate. Rate is always a percent, and it's something that we have to know how to convert. So there's multiple ways of converting a percent to a decimal. Okay, we'll get into that as we do our problems. And T represents the time period. For the most part, the time period is represented in years. But when you get to higher courses, you'll start to break it down a little bit more. Right? So what do these look like? Look at these two images. Which one do you think is exponential growth and which one do you think is exponential decay? Our first one here is exponential growth. Therefore, this one is exponential decay. Now, how do we know that? Think about it. Anytime we look at a graph, we read it from left to right. So what do you notice about the graph for exponential growth? It starts from a low point and it increases. Exponential decay starts from a high point and it decreases from left to right. Also, if you notice with these graphs, they do not touch 0. So as we have exponential growth or decay, it never crosses the x-axis unless we're changing, which you'll learn in your next course. We're changing the shift in the graph. So this graph will never touch the x-axis unless we shift in the graph. Okay? All right, so the first set of problems that we're going to be focusing on represent exponential growth. Okay, so once again, the rule is A is equal to P times 1 plus R to the T. All right, so remember, A represents your final amount, P represents your principal or your initial amount, R represents your rate, which is usually in percent, and then T is representing your time period. All right, so remember with this also, if we're looking at exponential growth, our growth factor is going to be greater than 1. So that means the sum of these two pieces will always be greater than 1. So by just looking at these three questions, we know that it's exponential growth because 1.02 is greater than 1, 1.017 is greater than 1, and 1.25 is also greater than 1. Now, how do we find the rate? So remember, rate is represented by R. This entire growth factor represents the sum of 1 plus the rate. So if we were to just make an equation, 1 plus R, we want it to be equal to our growth factor, 1.02. We're basically solving for the rate. So in this case, we would subtract 1 from both sides, and we're left with R is equal to 0.02. Now, this is not a percent. We need to convert it to a percent. And how do we convert things to percents? We move it 2 places to the right. So 1, 2. So this will be 2%. So in this problem, it's basically telling us that we have a growth rate of 2%. Our initial amount, which is also our principal, is usually the number right in front of our growth factor. So in this case, our initial amount is 1,300. And then our time period is represented by the T. In this case, our T is represented by 7. So it could possibly mean we're talking about something with a rate of 2% growing over a 7-year period. Okay, so let's just jump through the rest of them to make sure that we got this. The rate for the second one, once again, we know it's a growth factor because of this piece right here. So if I did 1 plus R equal to 1.017, we're subtracting 1 from both sides. So R is equal to 0.017. Once again, to convert a decimal to a percent, we move the decimal 2 places to the right. So in this case, it will be 1.7%. Our initial amount would be 1,350, and our time period for this particular problem is represented by T. Our last one, once again, our growth factor is here. So we have 1 plus R equal to 1.25. We want to subtract 1 once again. So R is equal to 0.25. To convert it, we move it 2 places to the right. And so we have 25%. Our initial amount is 100, and our time period is T. So when it comes to growth, we know it's a little bit easier to calculate because we could just look at the 1, we get rid of the 1, and whatever is left over, we know that's what it is, and then we move our decimal 2 places to the right to get our percent. Now, decay is a little bit more tricky, all right? So here are 2 problems. So once again, decay, we know it's decay because our growth factor would be between 0 and 1. So it will never fall to 0 or below 0, and it will never be greater than 1, right? So our growth factor here is 1 minus r. Sorry, our decay factor would be 1 minus r. But if you notice, this one is already set up in that format. So if I had 1 minus r, let's just set it up the same way. 1 minus r equal to 1 minus 0.12. If I were to subtract 1 from both sides, we have negative r equal to negative 0.12. But remember, anytime we're solving for a variable, we cannot have a negative variable. So we divide by negative 1. What we do to one side, we do to the other. So r is equal to 0.12. Once again, we must have a percent when we talk about rate. So we move it 2 places to the right, and that gives us 12%. Our initial amount is 21,000, and our time period is T. All right, now let's look at our last one here. If you notice, look at this factor here. It is less than 1. That's how we know it's decay. All right, so we have 1 minus r because that represents decay, and we want to get to a value of 0.98. We have to get r by itself, so we minus 1 from both sides. So we have negative r equal to negative 0.02. Right? Once again, we cannot have a negative variable, so we divide both sides by negative 1. So we're left with 0.02. Move it 2 places to the right. So our rate is 2%. We have 5,000 as our initial amount, and our time period in this case is X. So if you notice, when it comes to decay, we have to do a little bit more work because it's not as easy to calculate. If you do see the shorter version, by all means use it, but make sure you show your work. All right? So, break time. Be back soon. Down here. All right, welcome back again. So now we're into our second lesson, and in this lesson, we want to know how do we determine exponential growth and decay. All right, so if you don't have the calculator, make sure you get your calculator for this portion of the lesson because you're going to need it. All right, so let's get started. All right, so our learning objectives for this one is now we want to see the structure of the standard formula for the, no. So our learning objectives for this one would be we want to model the exponential growth and decay in real world situations. We want to write their own formula for exponential growth or decay and calculate the exponential growth or decay using the formula. So our first one says Daniel's print shop purchased a new printer for $35,000. Each year it depreciates, which means lose in value, at a rate of 5%. What will its approximate value be at the end of the 4th year? So I've left some notes down at the bottom here for you, some steps. And as we go through each slide, you will see them there, okay? So first thing is we want to identify if it's growth or decay. How do we know if it's growth or decay? It will tell us some kind of term of if it's going to be increasing or decreasing. In this case, it is going to be decay because it says depreciate as well as say loses value. All right. So now that we know that, we can identify our parts. We need to know what's going to represent A, P, R, and T. So based on the information here, it says that purchased a new printer for $35,000. We have a rate of 5%, and then we want to know by the end of the 4th year. So we want to know the approximate value, so that's what we don't know. So A will just still be A, right? P will be our initial amount or our starting amount, which is 35,000. Okay, our rate is 5%. And then the time is 4 years. So let's do our setup. Let's change the color. I gotta move my way out the way. Move my way out the way. Okay. So, oh, there we are. So our rule is A is equal to P times 1 minus R to the T because we are depreciating. Remember, depreciate means lose, so we use a subtraction. Now, when we were looking at the examples from the previous lesson, the rate was not in percent, but it was as a decimal. So how do we convert a percent to a decimal? Now with that, we just go the opposite direction. When we were doing a decimal to percent, we moved it 2 places to the right. Now we're doing percent to decimal, we're going to move it 2 places to the left. So where's my decimal right now? My decimal is here. So if I were to move it 2 places to the left, my decimal will be now here. But I have this filler, so we fill it with a 0. So now we have A is equal to 35,000 times 1 minus 0.05 to the 4th. So we have A is equal to 35,000 times 0.95 to the 4th. Now from here is just strictly calculating. So let's get to the calculator. So we have 35,000 times 0.95 to the 4th. And we get this value here of 28,507.17187, so on and so forth. Now, what are we talking about in this particular problem? We're talking about money. How many places after the decimal can we use? Only 2 places after the decimal. So if I were to write A is equal to 28507.71, I believe was 82, sure. All right. We all could only look at this particular decimal to round to. Now, if we're rounding, we have to look to the right. And this tells us if we're going to round up or leave it. If this number is 5 or more, we round up. If it's 4 or less, it stays. So for this particular problem, the approximate value would be $28,507.72. Okay, next one. The student population of the Brentwood Student Center is 2,000. The enrollment at the center increases at a rate of 4% each year to the nearest whole number. What will the student population be closest to in 3 years? So in this problem now, do we have growth or decay? This will be a growth problem because it says we're increasing. Okay? So we know we're going to be using the formula A is equal to P times 1 plus R to the T. Now, we need to identify our variables. We want to know to the nearest whole number the student population to be close to in 3 years. So once again, we're looking for A. We started off with 2,000 because it says right now, or the current student population is 2,000. So that's our starting point, our initial, our principal, all the same, all right? Our rate is 4%, and then we want to know after 3 years. So once again, we need to change 4% to a decimal. Right now the decimal is here, so we have to move it 2 places to the left, and we have to make a filler. So we have A is equal to 2,000 times 1 plus 0.04 to the 3. This is now A is equal to 2,000 times 1.04 to the third. When we calculate this, we go to our handy dandy calculator. We have 2,000 times 1.04 to the third. And we have 2249.72. So we have lost my pen again. There we are. 2249.72. But the question says we want to do it to the nearest whole number. Whole number. All right? So our whole numbers mean the digit before the decimal. Okay? So we're looking at this 9. So in this case, we're talking about population, right? So we want to round, although I mentioned in the last one, we want to round to the nearest whole number, but based on what I said with the previous one, if we look to the right, this is what determines whether we round up or we leave it, all right? Now, because we're talking about people, it varies. Can I have 2,249.7 people? No. So does that mean I add an extra body, or do I take, not necessarily take away, or I count less? In this case, we count less. So it becomes 2249. Okay? Right, next one. It says, the Booster Club raised $30,000 for a sports fund. No more money will be placed into the fund. Each year the fund will decrease by 5%. Determine the amount of money to the nearest cent that this will be left in the sports fund after 4 years. So, once again, growth or decay. I hope we all said it is decay because we see decrease by 5%. All right, so our rule is A is equal to P times 1 minus R to the T. All right, we're looking for A, P, R, and T. We want to know amount of money to the nearest cent that will be left, so we're looking for the total again. So A will be A. P is $30,000. R is 5%, and T we're looking at is 4. Once again, rate has to be converted to a decimal, so we start off with a 5. The decimal is after. We move it 2 places to the left, so it now becomes 0.05. So we have A is equal to 30,000 times 1 minus 0.05 to the fourth. This now becomes 30,000 times 0.95 to the fourth. Go to our calculator. 30,000 times 0.95 to the fourth. And we get 24,435.187. $24,435.187. All right. But once again, it tells us that we need to round. It says that we want to round to the nearest cent. Now, once again, how many cents, how many decimal places after the, how many digits after the decimal place does it represent for cents? 2 places. So we want to look at this 8, and then we want to look to the right of it. This case, it tells us that we need to round up. Has some technical difficulties. So let's continue. A is equal to 24,435.19. All right. Our next one. It says, on the day Alexander was born, his father invested $5,000 in an account with a 1.2 annual growth rate. First thing we want to do is we want to write a function, a of t, that represents the value of this investment t years after Alexander's birth. Then we want to determine to the nearest dollar how much more the investment will be worth when Alexander turns 32 and when he turns 17. So, a couple of things, all right? First thing, can we still identify if it's growth or decay? Absolutely. It says we invested $5,000 into an account. So that means we wanted to grow based on it saying 1.2 annual growth rate, all right? So we need to write a function, which we've been doing, but it specifies exactly how we need to write this one. So we need to start off with a of t. And in this case, a of t just represents our final amount. So our next thing would be the p, which is 5,000 times 1 plus r. We don't know what r is yet, but we're going to figure it out real soon. And then it says after t years. So this is just a t here. So our rate is 1.2, but remember we have to convert it to a decimal. So if I have 1.2%, let me put that percent there so we understand. And I want to convert it to a decimal, we move it 2 places to the left. So it becomes 1, 2. So we have that filler, right? So this is 0.012 here. If we want to rewrite it, you don't have to, but you can. 5,000 times 1.012 to the t. First part's done. Now the second part. It wants us to determine how much more the investment would be worth. So we have to calculate this 2 times. The first time, we're going to calculate at 32 years old. And then the second time, we want to calculate when he was 17 years old. So we have 2 different t's in this case. The first t is representing 32. And our second t is going to represent 17. Okay? So if I wanted to do A of t, which is 32 right now, equal to 5,000 times 1.012 to the t, which is 32. So if you noticed, I just plugged t into everything that is written in this rule that we created, all right? And t is represented by 32. So if we're to do that, we have 5,000 times 1.012 to the 32. And we get this big number here. So we have 7323.96743. Now, let's just look at the calculator. If I wanted to determine it to the nearest dollar, what will be the nearest dollar? 7324. Okay, so we're going to write A of 32 is equal to 7324. Now let's do the next one. We have A of 17 equal to 5,000 times 1.012 to the 17. So once again, we're going to go into our calculator, but instead of 32, we'll use 17. Apologies. Okay. And we have 6124.04984. Now, if I wanted to look at this to the nearest dollar, what will that one be? 6124. Now, what do I do with these two numbers? We have to subtract because it wants to know how much more investment will it be worth between these two ages. So if we were to do 7324 minus 6124, how much would we get? $1,200. Okay, so that's all for today. But now, just some reminders. Remember, on Tuesdays, you should be watching this video, taking notes, attempting the practice problems, and completing the classwork password. Remember, it will be linked in the materials with this video. If you did not see a password, please go back and make sure you watched the entire video. It appeared in the video somewhere and disappeared. Okay? On Thursdays, make sure to watch and edit your practice problems. So you should be checking your answers to make sure they're all correct. You're completing the exit slip and you're working on the homework. And remember, everything is due Sunday by 11:59 p.m. So remember, there are 4 things that you should be submitting: your classwork password, your notes, and practice problems. Make sure you're checking that rubric to make sure you get that perfect score. Your exit slip, which is graded on correctness, so take your time. It is not timed, so make sure you double check all your answers before pressing submit. As last but not least, your homework. Well, more is called purposeful practice at this point. All right, and also make sure you check that rubric to make sure that you are getting a perfect score on your homework. All right, until next time, take care.